Good afternoon, everyone. So welcome back to your favorite and India's most affordable learning platform, Physics Wala. So in the last session, we have dealt with the motion in a plane, lecture number 3. So where we discussed the concept related to the vectors, right? So the dot product and cross product especially. So in 3 lectures we have completed the entire vectors concept. Okay, chalo. So now today we are going to start the lecture number 4 of motion in a plane. So where we will discuss the relative motion in 1 dimension and the relative motion in 2 dimension, and if time permits we'll go for Rainman problems also. If not, we'll discuss it in the tomorrow session. Okay, as usual, for next 1 hour or 1.5 hours, just be with me guys and avoid all the disturbances around you. And at the end of the lecture, it's very important to write your own short notes. Okay, sure. So let's start with the today's topic. So that is relative motion in 1D. See, so the relative motion is nothing but the motion of one body with respect to the another body relatively. So relatively means the motion of a body with respect to another body, okay. So it depends on the frame of reference. So the relative motion, it's actually depends on the relative motion frame of reference. So what does it mean by frame of reference? So let's write. So what is the frame of reference? Let's understand the basics, then we'll go for the question solving. So the relative motion in 1D, I'll take at least some 10 questions and I'll explain you the concept through questions. Okay, so frame of reference is nothing but, let's suppose, so if I stand on the ground, so let's suppose a person is standing here. Okay, so then a bus is moving. So consider this is a bus. So this bus is moving with some velocity v. So now with respect to the person who is standing on the ground, so this bus is in motion. Okay, consider there is a person, so he is a person 1, let's suppose, and there is another person 2, right? So then I can say that, so with respect to the person who is on the ground, so the person 1 is in motion and person 2 is also in motion. Person 1 is in motion, person 2 is in motion. So whereas, so the person with respect to person on the ground, those two are in motion, but with respect to each other, so they are in rest. Yes or no? So the first person who is observing the second guy, so seems to be in rest. Yes or no? The bus is moving, they both are in rest with respect to each other who is sitting in the bus, right? So that's a frame of reference. The same two persons are in motion with respect to ground, but with respect to each other they are in rest. So this is called the frame of reference. Okay, so the relative motion changes so when you change the frame of reference. Okay, it depends on the frame of reference, I can say. Okay, clear this part? So now, so for example, the denotation we write here, for example, so the person A, let's suppose he is a person A, so he is moving with some velocity v1, okay, and the another person B, so who is moving with velocity v2. Okay, so now, so how do we write the relative velocity? So the relative velocity of person 2 with respect to person 1, the relative velocity of person 2 with respect to person 1. So we write simply v2 minus v1, simply v2 minus v1. So relative velocity of person 2 with respect to person 1, so v2 minus v1, or so the relative velocity of person 1 with respect to person 2, the relative velocity of person 1 with respect to person 2 is equals to v1 minus v2. So v1 minus v2. Clear? So just the relative velocity, not only in velocity, you can also relative motion, you can write it in displacement, that is relative displacement, relative velocity and relative displacement, all the relative acceleration, all these are possible. So for velocity you can write the relative, you can apply the relative motion. For displacement also you can apply the relative motion, not only for the velocity, and for acceleration also you can write. So for acceleration, the relative acceleration also we can write. Clear? This is just the basic thing about the relative motion in one dimensional motion. If they are moving in only straight line path, that's called one dimensional motion. So if the body is moving in the two dimensional motion, then we study the relative motion in 2D. So that we will study it in today's, I'll give the introduction in today's session. So then we will study it in detail in tomorrow's class. Okay, chalo. So see here, the relative displacement of B with respect to A. So here I am considering, so two bodies, consider this is the body A and then this is the body B. So this body A is, let's suppose this is the origin. So from origin, this body A is at a distance of XA. This body A is at a distance of XA and this body B is at a distance of XB. Okay, so and then this body A has velocity VA and body B has velocity VB, and the acceleration of A is AA, acceleration of B is AB. Okay, so now if we have to write what is the relative velocity of B with respect to A, the relative velocity of B with respect to A, velocity is a vector quantity, write it in the vector form. Okay, so the velocity of B with respect to A, so which is equals to, simply we can write, so velocity of B minus velocity of A, velocity of B minus velocity of A. Okay, so then, so we can also write with respect to ground, understand this statement. So we are observing this from the ground, the person who is standing here is observing from the ground. So that's why this is the velocity of B with respect to ground minus velocity of A with respect to ground. So this person is observing who is standing on the ground. Okay, similarly you can write the relative velocity of A with respect to B. You can write the relative velocity of A with respect to B. So this, how can we write? So the relative velocity of A with respect to B, VAB is equals to VA minus VB. So VA minus VB. So with respect to ground and with respect to ground. Clear this part? This is about the relative velocity. So similarly you can write for the relative displacement as well. So what is the relative displacement? So here I can write relative displacement of A with respect to B. Relative displacement of A with respect to B. So A with respect to B means relative displacement of A with respect to B. Okay, so which is nothing but displacement of A minus displacement of B. Okay, with respect to ground, with respect to ground. Done? Sure. And then, so you can also write, so the relative displacement of B with respect to A. B with respect to A. So that B with respect to A is equals to, so BG minus AG. That's it. So B minus A, XB minus XA with respect to ground and with respect to ground. Similarly, you can write it for the acceleration. See here, relative acceleration of B with respect to A. So acceleration of B with respect to A. So it's going to be ABG minus AAG. That's it. Done. Or else if you need the relative acceleration of A with respect to B, the relative acceleration of A with respect to B. So which is equals to, we can write this as, so A with respect to B, sorry, acceleration, right? AB. So which is nothing but, so AA with respect to ground minus AB with respect to ground. That's it. Done. Clear this part, everyone? Understood this procedure? The relative displacement and relative velocity and relative acceleration of one body with respect to the another. Okay now, so this concept we are going to implement on the problems. Okay, so let's start with the problems, the simple question, the first one. So let's start with the simple question, first one. Chalo. So see here, what's the question says? So a car A moves with velocity 15 meter per second and B with velocity 20 meter per second are moving in opposite directions as shown in the figure. So find the relative velocity of B with respect to A. So find the relative velocity of B with respect to A. First see here, this is the car A and this is the car B. So car A is moving 15 meter per second to the left, car B is moving 20 meter per second to the right. So now first thing is velocity is a vector quantity. Okay, now the sign convention is also important. So that's why what you do is, so towards right I am taking positive and then opposite direction obviously it will be negative, right? So now find the relative velocity of B with respect to A. What I have to find? So relative velocity of B with respect to A. What is the formula for this? So velocity of B minus velocity of A. VBA means VB minus VA. So with respect to ground and with respect to ground. So now the thing is, so what is the velocity of car A? Velocity of car A with respect to ground, I can write it as, so minus 15 meter per second. Why minus, sir? So because it is towards the left. So I considered my frame of reference as right side positive, left side negative. Okay, so throughout the question you have to follow the same. You should not change in the middle. So no sir, I'll consider left side positive, right side negative. No problem, consider it. But throughout the question follow the same. Okay, sure. So now the velocity of B with respect to ground is going to be again 20 meter per second. So 20 meter per second. So now simply substitute it in the formula. So velocity of B with respect to ground 20 minus velocity of A with respect to ground. So minus of minus 15. Right, so this is going to be 35 meter per second. So this is a 35 meter per second. Option A is the correct one. Simple question, basic one. Right? So let's move further. So let's take one more question. So what's the question says? A train is traveling with a speed of 15 meters per second and a man is walking inside the train at 1 meter per second with respect to train in the direction of train. Okay, so find the velocity of man with respect to an observer on the ground. See here, so here is a train. So consider, let's suppose here is a train. So then, so the train is moving at a speed of 15 meter per second. Fine. And then a man inside the train is walking at a speed of 1 meter per second. So the person is walking at a speed of 1 meter per second in the direction of train. So train is moving right side, let's suppose. So the person is also walking in the direction of the train. Okay. So next, so we have to find the velocity of man with respect to observer on the ground. So consider, let's suppose there is an observer who is on the ground. So let's suppose Chintu is a observer who is on the ground. So this Chintu is now observing this guy. So consider this guy as Bunty. So Chintu is observing Bunty. Okay. So that, so what is the velocity? Let's consider velocity of this man with respect to ground we have to find. That's what we have to do. So we find the velocity of man with respect to observer on the ground. So velocity of man with respect to observer on the ground. With respect to observer on the ground means with respect to ground. Okay. So this part we have to do. So the first thing is, what is the given information? Tell me. So what is the given information in the question? The train is moving at a speed of 15 meter per second, which is nothing but the velocity of the train with respect to ground is given. The velocity of the train with respect to ground. So let's consider right side direction as positive. That's why it's 15 meter per second. And then, so the velocity of the man with respect to train is also given. The velocity of the man with respect to train is also 1 meter per second because he is moving in the same direction. Yes or no? So now I am writing here. So let's take this one. So the velocity of the man with respect to train is equals to, what's the formula for this? Velocity of the man minus velocity of the train. Yes or no? With respect to ground, with respect to ground. Okay, chalo. So now we know the values, substitute them. Velocity of the man with respect to train, 1 meter per second. Velocity of the man with respect to ground, we have to find it. And then, so what is the velocity of the train with respect to ground? So which is 15. So from here, the velocity of the man with respect to ground, so which is going to be 15 plus 1, 16 meter per second. 16 meter per second. So this is the correct option. Option B is the correct one. So understood the concept? If the concept is clear, you can solve these questions very easily. Okay. Done? Next. So let's take the next question. So just pause the video and try it on your own, guys. Two trains, one 10 meters and then 90 meters long respectively are running in opposite directions with velocity 36 km per hour and 54 km per hour. So find the time taken by the two trains to completely cross each other. Okay, fine. See here. So this is the first train. So consider this is the first train. So, okay. So then there is one more train. So which is 90 meters long. So this first train is, consider this is 110 meters long and this is 90 meters long. Fine. Now, so the thing is, two trains, okay, the distance is given and the velocities. So they are moving in the opposite directions. So consider this is a train A which is moving at a speed of 36 km per hour. So convert this 36 km per hour to meter per second. So 36 into 5 by 18. So 5 ones are 18 ones are 18 twos are. So this is 10 meter per second towards right. And then, so then this will move towards left. So which is 54 km per hour. Again convert this 54 into 5 by 18. So which is nothing but 18 ones are 18 threes are 5 into 3. So 15 meter per second, which is moving to the left. So this information is clear. So now we have to find the time taken by the two trains to completely cross each other. So we know that the speed is equals to, or the velocity is equals to, so it's a total distance or total displacement by time. Yes or no? So now from here the time taken will be equals to, so the total displacement by the velocity. So here the two trains are moving opposite to each other. With respect to one another, they are moving opposite to each other. So then there comes a concept of relative velocity. Yes or no? There comes a concept of relative velocity. This velocity means, so the relative velocity. So so you can find sorry guys. So you can find, so let's suppose this is a A, this is B. So now what is the relative velocity of train A with respect to B you can do. Okay, or else, so train B with respect to train A, anything you can do, just we need the velocity, that's it. Okay, so A with respect to B, which is equals to velocity of A with respect to ground minus velocity of B with respect to ground. Okay, so now see here, so what is the velocity of A with respect to ground? So this train is moving to the towards the right. So I am considering right side direction as positive, left side direction as negative. So that's why the train A has velocity 10, which is positive 10 meter per second. And then train B is moving in the left direction. So 15. So therefore it's going to be minus 15, minus of minus 15, because it is moving towards the left. You can write it here. So the velocity of A is equals to 10 meter per second. So the velocity of train B is equals to minus 15 meter per second. So therefore the total relative velocity, so the V relative we say, whether it is A with respect to B or B with respect to A, so which is equals to 25. Yes or no? This we got. So now we need the total time. So now the total time is equals to, so now see here, so the time taken is equals to the total distance. What is the total distance? So shall I say the S relative by the total velocity V relative? Yes or no? So then what is the total distance, relative distance with respect to each other? The two trains have to completely cross each other. The two trains have to completely cross each other. when they completely cross each other, let's suppose train A is coming like this. So then train B is coming like this. So then the train 1 end and train 2 end, so they should come like this, yes or no? So train 1 is coming, train 2 is going. So then this train's end, first train's end and second train's end should be like this. So then we say completely crossed each other. So then first train has total 110 meters, second train has total 90 meters. So when they are completely crossing each other, the total distance is how much? 200, yes or no? So the S relative, I can say 200, yes or no? When they are completely crossing each other, so the total distance is going to be this one plus this. So total 200 by the V relative 25. So which is 25 8 times. So that's why, so it's going to be 8 seconds. In 8 seconds, so they completely cross each other. Option D is a correct one, guys. Clear? Understood the concept again? Done? Sure. So next question. Let's go for the question number 4. A train 150 meters long length is moving towards north direction at a speed 10 meter per second. Okay. A parrot flies at a speed of 5 meter per second towards south. Okay. So direction parallel to the railway track. So the time taken by the parrot to cross the train is. Okay. So the time taken by the parrot, so to cross the train. So see here. Again the simple concept. So first there is a train. So this train is moving towards north. So let's consider this side, it is north. So I am considering the directions. So this side I am taking north and then this side I am taking south this time. Okay. Chal. So it is moving at a speed of how much? 10 meter per second. Fine. Next. So next. A parrot flies at a speed 5 meter per second towards south. So parrot, let's suppose the parrot is here. So it is moving this side with a speed 5 meter per second. Fine. Now, so towards the railway track. So the time taken by the parrot to cross the train. So what is the time taken by the parrot? The time taken by parrot to cross the train. To cross the train. So the time taken is again going to be same. So the S relative by V relative. So S relative, V relative. So the parrot is crossing the train. So that's why the total distance the train parrot covers is going to be, so obviously that train length, which is 150 meters. So now what I am doing is, so sign convention is very important, guys. So let's consider right side direction as positive. Right side direction as positive. Obviously the left side direction, south side direction is, it will be negative. Now see here. So now observe carefully. So we have got, so the train velocity, the velocity of train with respect to ground, the velocity of train with respect to ground, it's going to be 10 meter per second. Now the parrot is flying 5 meter per second towards south. So south side. So the velocity of parrot with respect to towards, so the velocity of parrot, it's going to be 5 meter per second. Yes or no? Minus 5 I'll write. So it's going to be minus 5. So then the time taken. So what is the total relative distance that it covers? What is the total relative distance that it covers? Tell me. Tell me the total relative distance. So it's going to be simply 150. It's going to be simply 150. The total distance that covered by the parrot is going to be the train length. So now I will take it as minus 150. I'll take it as minus 150. Why? Why? Tell me. Why minus 150? Why minus 150? Because it is moving from south towards the south direction. Here it is starting. Towards the south it is moving. So towards the south means this side it's negative. So that's why S relative, the displacement, I am taking it as minus. Now the thing is, so what is the V relative? What is the V relative? So the V relative is nothing but what is the velocity of the parrot with respect to train? What is the velocity of the parrot with respect to train? So which is going to be velocity of parrot minus velocity of train with respect to ground? Yes or no? So then this is with respect to ground, this is with respect to ground. Here it is given with respect to ground. Okay, so now see here, velocity of parrot with respect to ground, so which is -5 towards left, right? So -5 minus velocity of train with respect to ground, which is 10. So that's why this total is -15 meter per second, -15 meter per second. So that's why it's going to be -15. Yes or no? So then minus minus cancel, 150 by 15, so 10 seconds, that's it. So the correct answer is 10 seconds. Hope you guys understood the concept. Clear? Any doubts here? Just the sign conventions you have to take care. So why this is -5? Because it is moving towards the south direction. See here, it towards south direction. So we consider north as positive. That's why train velocity, I took it as positive. See here. So the train velocity of the train with respect to ground is 10. So velocity of the parrot with respect to ground, so -5. And the relative distance also you should take it with the sign. Why? Because it's moving towards the south direction, right? South direction, negative. All the vectors which are in the south direction should take it as negative here. So that's why the relative distance is the vector. So that's why I took it as minus. Clear? Understood? So let's take the next question. A bus is moving with a speed, so 10 meter per second on a straight road. So consider here is the bus. So this bus is moving with a speed of 10 meter per second. So let's consider it is moving towards right. So then a scooterist wishes to overtake the bus in 100 seconds if the bus is at a distance 1 kilometer from the scooterist. So here is the scooterist. So the person who is sitting on the scooter, and then he wished to overtake the bus in 100 seconds. So how much distance between the bus and the scooterist? So 1 kilometer. So let me take it as 1000 meters. Okay. So then with what speed should the scooterist chase the bus? With what speed should the scooterist chase the bus? So velocity of the scooterist with respect to bus. So that we have to find. What is the velocity of the scooterist with respect to bus? We have to find. Okay now. So the first thing is, so what's the given information? Tell me here. So the bus is moving. The velocity of the bus with respect to ground, it is given as 10 meter per second. This is the first thing. And the total distance is given. So the total distance means the relative distance between the scooterist and the this one. So the S relative is given. So how much? Which is 1000 meters, right? So then what we required? So and what else is given? So the time is given. So the total time is given. So what is the total time? So let it be 100 seconds. So let it be 100 seconds. So now the concept is clear. You know that the total time taken will be equals to S relative by, so the V relative, S relative by V relative. So here the time taken is how much? 100 seconds. And the distance that it covers is 1000. And the what is V relative? The velocity of scooterist with respect to bus. So let's consider the velocity of the scooterist is V. So then velocity of scooterist with respect to bus will be equals to, so velocity of scooterist with respect to ground minus velocity of bus with respect to ground. So we don't know what is the velocity of scooterist with respect to ground. So let it be V. So okay, V minus, so velocity of bus with respect to ground, so 10. So consider it as V minus 10. So therefore this is a V relative. This is nothing but the V relative, right? Velocity of scooter with respect to bus is nothing but the V relative. Scooter with respect to bus, right? So then I can substitute here V minus 10. So here two zeros cancel. So I can write V minus 10 is equals to 10. So from here V is equals to 20 meter per second. So what is V? So the velocity of the scooterist, with what speed should the scooterist chase the bus? So with what speed he should chase? 20 meter per second. Option D is the correct one. Clear? Everyone understood this concept? Chal, next. So let's move for the next question. A man is 25 meters behind a bus when bus starts accelerating at 2 meter per second square acceleration, and man starts moving with constant velocity 10 meter per second. So the time taken by him to board the bus. So understand the concept. A man is 25 meters behind the bus. So here is the man and here is the bus. Okay, so the distance between these two are 25 meters. So this part is clear now. So the bus starts accelerating. See here, hint. The bus starts accelerating. So initially the velocity of the bus with respect to ground is 0. So it starts accelerating. Just now it starts accelerating. So the velocity of the bus with respect to ground, so it's 2 meter per second square. It's 2 meter per second square. And a man starts moving with a constant velocity. The velocity of man with respect to ground is given. So which is 10 meter per second. So then the time taken by him to board the bus. So the time taken by him to board the bus. So they said the man is moving with a constant velocity. The man is moving with a constant velocity. So now what I am doing is I need the time taken. We have to find the time taken. So here acceleration is also included. See here, the velocity of the man with respect to ground, it is 10 meter per second. Yes or no? And then velocity, the acceleration of the man with respect to ground, it's going to be, shall I say, 0. The acceleration of the man with respect to ground is going to be 0. And then, so from here, next let's write, so the velocity of the bus with respect to ground, it's going to be 0. And acceleration of the bus with respect to ground is going to be 0. Yes or no? Clear this part? So now what we need, the total time taken. So the total time taken for here, so I am using S is equals to ut plus half at square, where so this u is a relative velocity and this a is a relative acceleration. So yes or no? So what is the acceleration of the man with respect to, so see here, simply find what is the velocity of the man with respect to bus. We have to find what is that. So velocity of man with respect to ground minus velocity of bus with respect to ground. So what is the velocity of man with respect to ground? 10 minus velocity of bus with respect to ground 0. So this is 10 meter per second VMB. This is a relative velocity. And then so what is AMB, velocity of acceleration of man with respect to ground. So which is acceleration of man minus acceleration of bus. So with respect to ground and with respect to ground. So that acceleration of man with respect to ground 0, and then acceleration of bus with respect to ground, sorry, this is 2 meter per second square. So this is 2. So that's why it's going to be minus 2 meter per second square. So this is nothing but V relative. We call it as V relative, velocity of man with respect to bus, because he has to board the bus. The person has to board the bus. Let's make him the subject. Understanding, guys? So with how much speed he should move. That's why the velocity of the man with respect to bus. And then what is the acceleration of the man with respect to bus? So then this one. This is a relative. So now in this equation, this u is the u relative, a is the a relative, and this s is the s relative. How much distance he has to cover? 25 meters. So consider this as 25 meters, and then u relative. So what is u relative? 10. So what is the time taken? So we have to find. So plus half a. What is a? Minus 2, and then t we have to find. So now the simple task. So 25 is equals to 10t minus t square. Yes or no? So here 2 cancel, minus t square. So that bring everything to this side. So t square minus 10t plus 25 is equals to 0. So then I can write t square here minus 5t plus 25 is equals to 0. So then t if you take common, so t minus 5, and then minus 5 if you take common, so t minus 5. So which is equals to either t minus 5 is equals to 0 or t minus 5 is equals to 0. So that means t is equals to obviously the 5 seconds. So the correct option is t is equals to 5 seconds. Option D. Concept clear? Everyone? Just I am increasing the difficulty level of questions one by one. Okay? Understanding? Chalo. So just note this down. So next, a ball is dropped from the top of a building 100 meters high. So see here, this is a 100 meters tall building. Let's consider this is a 100 meters tall building. The total distance is 100. So now next, so at the same time, at the same instant, so one ball is dropped. Let's consider the ball A is dropped. So dropped in the sense its velocity, initial velocity is 0. Now, so at the same instant, another ball is thrown upwards with a velocity 40 meters per second. So consider this is a ball B, so which is thrown upwards with a velocity 40 meters per second. So this is a velocity of ball B. So and velocity of ball A with respect to ground, it's going to be 0. Velocity of ball B with respect to ground, it's going to be, let it be 40 meters per second. Fine. So now from the bottom of the building, so the two balls will meet after. So interesting question. So how can we solve this question? By relative velocity. See here. So the first thing is we have to find the time. Yes. So we know the relative distance, how much distance they have to cover. How much distance they have to cover. The total building height is 100. Yes, relative is going to be 100. The two balls, when they meet, so they combinedly cover a distance of 100. Let's suppose this ball comes here and then this ball comes here. So this covered some 60, this covered some 40. Yes or no? So then the total relative distance covered by both of them will be obviously 100. Yes or no? Yes, relative we know. So then this is moving with a speed of 0 and this is moving with a speed of 40 meters per second. So first I am going to use the simple equation S is equals to ut plus half at square again. I am going to use the equation ut plus half at square. S is equals to ut plus half at square. So here this S is a S relative. Let me write this way. Understand the concept. S is equals to ut plus half a t square. So here S is the S relative, so U is the U relative, and then A is the A relative. So this thing you should understand, that's it. So what is the relative velocity with respect to one another? So the first thing is, so the relative distance, so consider the relative distance. So with respect to relative distance means, so the displacement of A with respect to B. A with respect to B, as A is coming down, so I am taking it as minus 100. Why? Because I am considering A with respect to B, the relative displacement of A with respect to B. So B, let it be, B is in rest. With respect to B means B is in rest. So we are moving A. So A is moving downward. So that's why minus 100 I am taking. This part is clear. So now while considering the velocity also, what you should do is, the V relative means velocity of A with respect to B only you should take. Okay, understanding this concept. If you take the S relative as, so displacement of B with respect to A, so then consider velocity of B with respect to A, and then acceleration of B with respect to A. This is very important. Okay, so chalo. So velocity of AB is nothing but VA minus VB. So with respect to ground, with respect to ground. So what is the velocity of A with respect to ground? 0. And what is the velocity of B with respect to ground? 40. So this is going to be minus 40 meters per second. So throughout this question, follow the sign conventions, guys. So upside positive, downside negative. Okay, that's what I followed. See here. So this is minus 0 means no need to put minus 0, right? So minus here. So VBG. So take it as positive 40. So that's why minus 40 meters per second. So we have got S relative, V relative. So these two terms are clear. Then we have to find A relative. Now the thing is, what is the acceleration of body A? While coming down, the acceleration of body A is going to be simply G. So which is minus G we can take. The acceleration is always negative. So this we discussed it in the motion in a straight line. So then velocity of body B, the acceleration of body B with respect to ground, again it's going to be negative. Acceleration, whether it's upward or downward, always negative. So then, so what is A relative? So now the thing is, I need the A relative. So just let it be aside. So then I need the thing, what is A relative? A relative is nothing but again acceleration of A with respect to B. The displacement of A with respect to B. velocity of A with respect to B. Similarly, you can take acceleration of A with respect to B. So which is nothing but acceleration of A minus acceleration of B. So with respect to ground, with respect to ground. Okay. So from here, acceleration of A with respect to ground, so minus G, minus acceleration of B with respect to ground, so minus G. So then this is going to be minus G plus G, so which is 0. So the relative acceleration is 0 in this case. Now simply use the equation. So what's the kinematic equation we can use? S is equals to ut plus half at square. S is equals to ut plus half at square. So which is S relative, this is U relative, and then this is A relative. So then, so shall I write S relative as, so how much distance it is covering? So minus 100 I am taking. Minus 100 I am taking because with respect to A I am writing. So A is moving downward. Okay now. So in relative velocity, A with respect to B means you are making B in rest and moving A. You understanding? So your B is in rest with respect to something means that is in rest, relative motion. Okay. So then this is minus 100. So this part is going to be completely 0. Why? A relative is 0. Okay. And then U relative, what is the U relative? So U relative is minus 40 and the time taken, let it be time t. So then here minus minus cancel. So then 0 0 cancel. So the time taken is equals to 10 by 4, which is 2.5 seconds. So 2.5 seconds is the correct answer. Option B. Clear the concept, everyone? So next, let's move for the next question. So try to understand the question. A ball is dropped from a high-rise platform at t is equals to 0. So starting from the rest. So high-rise platform means let's consider that as some building again. So consider this is a building. So from there a ball is dropped at time t is equals 0. So after 6 seconds another ball is thrown downwards from the same platform with a speed v. So here two things. So the first one is just dropped. Consider this is a ball A which is simply dropped. Okay. So then it is covering some distance. Okay. Next. So there is ball B, so which is thrown with some velocity v. So first ball is just dropped from some height, second ball is thrown downwards. This is clear? Chal, next. So what they said next, the two balls will meet at t is equals to 18 seconds. So the two balls will meet at t is equals to 18 seconds. So initially the t is equals to 0, ball A is dropped. After 6 seconds, so the ball B is thrown downwards. So then they both will meet at t is equals to 18 seconds. They both will meet. So A and B will meet here, somewhere around here. So then what is the value of V? Find the value of V. So take the G value as 10. That's what they said in the question. Yes. So now the thing is, so first understand the concept. So first body A is dropped. So what is the distance covered by body A? First thing, the distance covered by body A in 6 seconds. After 6 seconds of fall, how much distance the body A has covered? So for that, S is equals to, I am using ut plus half at square. S is equals to, I am using ut plus half at square. So then, so what is the distance that we have to find? So which is equals to, so initial velocity is 0, so this term will become 0. So A, and then this is, however, the displacement as it is coming down, so minus we take. So then let's write it. So then A is minus 10, so t square 6 square. So which is 36, so 36 means 18, so that is S is equals to, however, we are getting minus 180. So that means minus, this minus indicates what? This minus indicates, so with like downward, so it's traveled, how much distance? 180 meters distance in how many seconds? 6 seconds. 6 seconds. Now the thing is, so after 6 seconds the ball B has thrown downwards. After 6 seconds the ball B has thrown. So then after t is equals to 18 seconds, at t is equals to 18 seconds, they both are met. Okay. So then what is the time taken by the ball B? Tell me. What is the time taken by the ball B? So to reach the ball A, obviously 12 seconds. Yes or no? Ball A has already dropped 6 seconds prior to the ball B. So now they both are meeting at the 18 seconds. T is equals to 18 seconds. So T is equals to 18 seconds means body A has traveled till 18 seconds. Now body B is just taking 12 seconds to reach the distance, reach the A. So can we find what is the velocity of, see here. So what is the velocity of ball A after 6 seconds? After 6 seconds of fall. So then V is equals to, you can write U plus AT. So then V is equals to, its initial velocity is 0. So what is A? A is, let's consider, what is A? A is 10 minus G, so into time taken. So what is the time taken? So 6 seconds, right? So this is going to be, V is equals to, so this is going to be, so this acceleration should be taken as negative, right? So therefore V is equals to minus 60. So this is the velocity of A after 6 seconds. Velocity of A after 6 seconds. So now I am going to use the equation, so that is S is equals to UT plus half AT square. S is equals to UT plus half AT square, where here U is the U relative and S is the S relative and A is the A relative. Okay. So the first thing I have to find, so the relative distance covered by the B with respect to A. So the S relative is going to be, so the B has to cover 180 meters, I can say. Yes or no? So the B has to cover 180 meters downwards. So that's why S relative directly I can write minus 180. So now, so what is U relative? Tell me. What is U relative? So the velocity of B with respect to A. The velocity of B with respect to A, which is nothing but velocity of B minus velocity of A. So with respect to ground and with respect to ground. So what is velocity of B with respect to ground? So it is thrown with a velocity, how much? Minus V. Downwards means you can take it as minus V minus velocity of A with respect to ground is minus 60. So that's why it's going to be 60 minus V. This is the U relative. So now you got the U relative. So now let's go for, so what is A relative? So let's write this equation later. So let's write what is A relative. The A relative means the acceleration of B with respect to A. So which is acceleration of B minus acceleration of A, obviously. So acceleration of B is minus G. So minus of minus G. So which is going to be 0. So A relative is 0. So from here I can write the S relative is equals to, so U relative into T plus half A relative T square. That's it. This is a concept you should understand. Okay. So what is S relative here? The S relative is minus 180. And then U relative is, so 60 minus V, na? Yes, 60 minus V. And time taken, let it be 12 seconds. Why 12 seconds? Because the body A has already covered 6 seconds. And body B is taking 12 seconds to reach the body A, right? Yes or no? Body B is reaching 12 seconds to reach the body A. So body A, how much distance it covered? The relatively 180. So that's what we substituted. This whole thing will become 0. So plus 0. So I can write minus 180 because here A relative is 0. So whole thing will become 0. So here it is 60 minus V into 12. So then I can write, so 12 ones are, so 12 ones are and 6. So 12 15s are. So minus 15 is equals to 60 minus V. So from here V is equals to 60 plus 15. So which is 75 meter per second. So the ball B has thrown with a velocity 75 meter per second. So choose the approximate answer. Here 74 is given. So choose the appropriate answer, like close one. So which is 74. Clear? Understood everyone? Done? Sure. So the next, so the relative motion in 2D. So the relative motion in 2D is still now whatever we discussed, it's a one-dimensional motion. So if the body is moving in two-dimensional, like XY plane, for example, so let's say a body So one body is moving due east with some velocity, and the another body is moving due north with some other velocity. So let's suppose due east with a velocity v1, so due west with a velocity, due north with a velocity v2. So if they say find, so consider this is body A, consider this side it is moving with body B, find, so the relative velocity, find the relative velocity of A with respect to B, of A with respect to B, of A with respect to B. So how do we do that? A with respect to B, sir, this is moving with, so let's suppose some V1, so V2 also equals to V. Sir, V minus V0, no, so don't do that. So this is a velocity of A with respect to B. So what does that mean? Velocity of A with respect to ground minus velocity of B with respect to ground. Yes or no? So here A1 is moving in east direction, B is moving in north direction. So I can say that, so the VA minus VB, so VA minus VB, so which is nothing but, let's consider this is V1, so this is the VA is V1 minus VB is V2, VB is V2. So then what we have to do, the vector form, the vector subtraction we have to do. So V1 minus V2, so what we have to do, so the resultant, so just simply V1 and this is minus V2, right? Reverse this vector. In vectors we have seen kada. So this is going to be minus V2, so the resultant is this one. So this is a resultant. Which direction it is? So this is east, north, so this is going to be west, this is going to be south. So this is going to be southeast direction. The resultant is going to be in the southeast direction. So let's suppose if it is V, so its magnitude also V, so then obviously it's going to be the magnitude of V root 2. Yes or no? So V root 2 meter per second, southeast direction. So this is the 2D. So let's take one question so that you'll understand even better. So let's consider this question, guys. So what's the question says here? A particle A moves due north. So consider this is a particle A which moves due north. So consider this is the direction, east, west, north, south. Okay. So due north at 3 km per hour. So this is A with 3 km per hour. So then another particle B due west. So this is moving B particle, so which is moving 4 km per hour. Fine. So next. So the relative velocity of A with respect to B. So what we have to find? The relative velocity of A with respect to B. So then what we write? Relative velocity of A minus relative velocity of B. Relative velocity of A with respect to A minus B. So don't just cancel, sir. This is 3, this is 4. So VA minus VB means 3 minus 4 minus 1. No. So is there any option minus 1? No. So what we have to do? So VA minus VB, velocity of A with respect to B. So VA minus VB means what we can do? So can we parallel, can we shift this to this side? This is a VB, this is minus VB. Yes or no? So then the resultant of these two, so this is going to be how much? 4. So this is 3. So the resultant of these two is this one. This is going to be the resultant. Yes. So the resultant is in which direction? This is north, this is east. So which is going to be north, northeast direction. So obviously if it is 4, this is 5, simply this is going to be 5 meter per second. Basic knowledge, basic things. We are just doing the basic things. See, VA minus VB. So minus VB means this side the vector will come. So then what does it mean by VA minus VB? So the resultant of these two will obviously come in this direction. We know that, right? So and then, so now the thing is we have to find, so 5 km per hour is there here and 5 km per hour is there here. So then these two ruled out. So 37 degrees north of east or 37 degrees east of north. So then what does this mean? So here first to find this angle, how much is this angle? So if you parallel shift this one here, so this is going to be 3, this is 4. So tan 37 is 3 by 4 means this is 37 degrees. Yes or no? So and this is going to be 53. So north of east or east of north, how do we say? So the thing is here it is going to be towards north. So it is going towards north from east, right? So we write this angle as 37 degrees north of east. 37 degrees north of east. 37 degrees north of east. Clear? Understood this part? So or else I'll give you the more examples. So let's suppose, so this is a east west, so the vector is here. So consider this angle is 53 if I say. So then this is north and this is east. So it is going towards east. So 53 degrees east of north. So this is 53 degrees east of north. Clear? So whereas, so if I say the vector like this, so consider this angle as some again 53. So then what do we write? So this is south, so this is west. So how do we write this angle? So this is 53 degrees west of south. 53 degrees west of south. So from south you are going to the west. Here from east you are going to the north. So that's why 37 degrees north of east is the correct answer. 5 km/h, 37 degrees north of east. So not east of north. East of north means, so towards east it should come. So this angle, if it is 37, so then we say this one, right? So or else here you can say that 53 degrees east of north, if they give the option, that's going to be the correct. If they give 53 degrees east of north, so then it's going to be correct, guys. Clear? Understanding the concept? Just the basic things. So this is about the relative motion in 2D introduction just. So then reverse swimmer problems, so aeroplane wind questions, and then rain man problems or rain woman problems, umbrella questions, so and then collisions. So all these we are going to discuss it in the next session. Okay, so what we discussed today, so just the relative velocity concept through different questions. I took almost some 10 questions today. So through these questions I discussed the complete relative motion in 1D. So just I gave the introduction to relative motion in 2D. Okay, so next class we'll cover the remaining topics. So till then, keep studying. All the very best, guys. Bye. Take care.